In this short presentation, I'm going to show you how we can make economics more scientific and actually more theological in one go. So the key word is truth. I want to make it sort of truthful in both senses, okay, in the sort of moral, theological sense as well as a scientific sense. So how do I start off with? I start off with a sort of chapter 1 of Mankiw, where you think about the way we calculate GDP. So gross domestic product, the amount produced in an over, say, a year or quarter in an economy, the amount of goods and services produced. So we add up all the incomes, or we add up all the expenditures, or all the output, and it should be equal. But let's focus on incomes and expenditures. So the way my framework works, and I think this is useful to anyone who is interested in the macroeconomics of debt. It's a model of debt, and I'm going to look at incomes equaling expenditure. So I have a 45-degree line, or you could say y equals x, incomes equal expenditure. So this is a sort of truth that I think one can build up a sort of theology from, but also a science. And when I say theology, I'm talking about Judeo-Christian biblical scriptures. And it's not obvious from this, but I'll give a sense of why that is, because you can think of debts as sort of in a kind of moral way. If you look at the Lord's Prayer, for instance, or whatever. So along this line, if I have a unit of income here, it's going to equal expenditure. This is also going to be associated with debts not being in the system in some sense. So on aggregate, in a closed economy, you'd say net debt sums to zero. Right, but how do you get any further than this? Okay, well, if every individual was on this line, there would be no debt, because every individual's incomes would equal their expenditure, so there'll be no debt. But this doesn't have to be so, obviously. So debt allows us to decouple our incomes from our expenditures, and that's what permits debt. So how can we capture all debt in one go? So this is how I do it. I split the economy into debtors, so two representative agents, so not kind of single representative agent, but two, debtors and creditors. So what I do need is a finite time period, such as a natural cycle, like a lunar cycle, like a monthly cycle, a yearly cycle, but it doesn't matter, it just has to be some time t over which we can define people's creditors and debtors. So at the halfway point, did you spend more than your income? Debtor. If you spent less than your income, you're creditor. And there's going to be symmetry at play. Okay, so let's say cap t is the full time period. So now I can use Pythagoras theorem, and this is the key kind of innovation of my work, is if you've got two squares that sum to a bigger square, what I can do is I can take the sides of each square, okay, and I can take that as debtor income, the smallest square, and it's going to equal the other side, which is going to be creditor expenditure. Excuse the messy handwriting. And this is going to be creditor income, and this is going to be debtor expenditure. So the debtor's expenditure is greater than their income. Remember, this is a partition of the economy. Everyone's in one and only one group of a closed economy, and you're going to have a symmetry. The debtor income is going to equal the expenditure, it's going to equal the creditor expenditure, and vice versa. And the whole economy, as it pertains to debt, is going to capture this. And all debts are going to be flowing between the groups, crucially. So now, once you have got this sort of conception, we can plot it very nicely and think about how this works. So you can have creditor income, creditor expenditure, debtor income, and debtor expenditure. Creditor income is going to equal creditor expenditure. No, creditor income is going to be equal debtor expenditure. So we're going to have a square there. And debtor income is going to be equal creditor expenditure. So we've got these two squares, and in what sense do I add them up to 1? Well, what I do is I'm thinking about the interactions between the two, and I'll say that debt is composed of 100% of the flows between the two groups, and so between the two they're going to make up all debt transactions. So you can think about the extremes between the two. And then, if you think of an intertemporal budget constraint, each has an intertemporal budget constraint that will look something like this. So you'll have cap T split into 2 periods. You've got period 1, consumption, plus period 2 consumption over 1 plus R equals period 1 income plus period 2 income over 1 plus R. We can ignore the R, and we're just going to have this this is kind of representing that incomes and expenditure. I'm kind of mixing terms here, but okay, mixing terms a bit, but they're going to have a variation of income and expenditure. But over time, by cap T, there's going to be an equality of the individual's incomes and expenditure. So there's like a transversality condition or no Ponzi scheme condition. And so by the end of the period, everyone's going to be along this 45-degree line. And therefore, if you've got these two squares, they will have to equal one another. Okay, so that is the concept of that. How do I make it more theological? I won't show you now, but the whole point is roughly that once you do a sort of equality of these two, you can compare a non-debt economy along this line to one where there is debt, and you can compare the two. And what's going to happen is the sort of link between a non-debt and debt economy is going to relate, at least approximately, or maybe at least approximately, to the same sort of concepts of non-debt versus debt. Sort of, I'm going to say time. Okay, you can link time is money, so it's kind of that idea. And this ratio is going to be approximately 6/7, so it works 6 days by 7, and you're going to see that in the geometry, and that's what's really interesting. A scientific approach to economics leads you to sort of the theology, so you've got this unified framework. So that's what my framework looks at.